Okay, I'm going to do my best here to show you the general idea of how to find the slope of a tangent line to a function at a particular point. So let me switch to another program that I use called GeoGebra. So what we're going to do is try to, we've got this function f of x here. That's the parabola that you see. And I've got a point here on the parabola. You can ignore all this stuff over here to the right. I have a point on the parabola, and this red line is what we call the tangent line to the curve at this point. It's tangent because it touches at only that one point. It just grazes the curve. Okay, so this line is interesting for many reasons. One of the reasons is because if you were to zoom in on this point, this line behaves just like this function, or this function behaves just like this line if you zoom in enough around this point. Okay, but usually to calculate the slope of a line we need 2 points, and here we only have one. So the idea to calculate this slope is to use limits. So let me show you that. We're going to use this blue line to approach this red line so that we can use the limit idea. So you can see down here the horizontal distance between the 2 points, this fixed point that we've got, the point where we need to find the slope of the tangent line. The horizontal distance h from here, this point, to the mobile point that we'll be moving in just a minute is 2.93. So this blue line here is what we call the secant line. Okay? And so the secant line always has 2 points. And we'll see how to do this in a minute. The secant line, if we want to adjust this mobile point here, I'll go up here and do that. You can see what happens as my h value gets smaller, meaning this point gets closer and closer to my fixed point. The horizontal distance is shrinking. As that h value gets closer and closer to 0, those points get closer and closer together, and you can see the secant line, the blue line, is starting to look more and more like the red line. Okay? And so the idea is whenever h gets to 0 or close to 0, you can see here that the blue line's even really close to the red line. And so what we can do is we can take this limit as the distance between the 2 points decreases to 0. So we would take the limit as this h value goes to 0, and that would end up giving us the red line. Okay, the idea is we're gonna find the slope of the blue line. We can do that because we actually have 2 points, right? You can find the slope if you have 2 points. And then we're going to take the limit of that slope as that h value goes down to 0, because when it reaches 0, that blue line becomes the red line, which is the tangent line. So the idea is we're going to take a limit as this h value goes to 0 of the slope of the blue line, and that will give us the slope of the red line. So let's see how to do this. Okay, so here's our picture with the secant line and the red tangent line. Okay, here's the idea. We're going to measure this distance and call it h, the horizontal distance between the fixed and the mobile point here. And this point here will always be given. Okay, so let's call this point, let's call this ordered pair a, comma. Well, since the function is f of x and this point is on the curve of the function, the y value would be f of that x value a. So this ordered pair is a, comma, f of a. This point over here then, since its x is h more than this x value would be a plus h. And since this point, the mobile point, is also always on the curve of f of x, the y coordinate would be f of a plus h. Okay? So now we can find the slope of the secant line. Let me write that. I'm running out of time here. So you take the 2 y coordinates of the 2 points and subtract those to get your rise on top, and the difference between the 2 x values to get your run on the bottom. So this is the secant slope. The tangent slope is what you get when the limit as h approaches 0 is taken of this slope, because as h goes to 0, the blue line becomes the red line. So we're going to take the limit as h approaches 0 of the secant slope, which is this thing up here. And so this is the slope of the tangent line. So once you know your function f, you could literally plug in these values, and once you know this ordered pair, you could plug in the values for a. And in fact, this will always simplify in a certain way. Let me show you. This denominator will always be h. So you can see you'll have to do some algebra to do the limit.